This whole demonstration is about impedance. Now this is very interesting because what you measure on this inlet valve coil in terms of resistance is going to be vastly different in the eyes of an AC voltage source. So if you were to connect DC to this coil, the DC voltage would see reading 188 ohms. Okay. Okay, so what that would tell us, if we had 120 volts going through, 120 volts of DC, our current going through this coil would be 120 volts divided by 188. That is 0.64 amps. So we would have 0.64 amps going through this if this were a resistor. Okay, so, but to an AC voltage, this is going to look much higher because this has impedance. Coils, all coils are going to have impedance. Motors have impedance, and inlet valves have impedance. So when we hook up 120 volts to this, we're going to see a lower current than 0.64 because the ohms that it is going to be seeing is going to be much higher than 188. Now just to confirm that DC voltage will see 0.64 amps or 188 ohms, I'm going to go ahead and hook 12 volts to this. I'm going to divide that by 10, and since the Ohm's law triangle, the current is proportional to voltage, we should actually see somewhere 0.064 amps if I hook 12 volts across it. This would be with DC voltage. We're just going to confirm that by hooking DC voltage to this, that we're going to get the expected reading. And I have this power supply set for 12 volts right now, 1.99 volts. And right now, we're getting 0.063 amps. So that is right on the money, pretty much, for a calculation, or a proportional calculation. So now, let's hook up 120 volts AC to this. Don't try this at home because this is mains voltage here. But I am a qualified technician, and anybody that does this should be qualified technicians. So let's go ahead and do that. Okay, so we have this all set up here, and our meter is going to read, our Klein meter is going to read the current draw through this inlet valve coil, and we're expecting it to be a lot less than 0.64 amps because of the impedance of this coil should be a good bit higher than 188 ohms. It should see a lot higher ohms than that. So I'm going to go ahead and plug this in and get our reading. .44 amps. 0.43 amps. Okay, so what does that tell us? 0.43 amps. Well, we can easily calculate the impedance of the coil now. The impedance in ohms is going to be voltage divided by current. The Ohm's law triangle still applies when you're doing RMS. You're going to replace the resistance with impedance. If we're just doing simple RMS, we have one load, one reactive load that has impedance. So that is going to be 120 volts divided by 0.44 amps equals that gives us 273 ohms. So instead of 188 ohms, we got 273 ohms. That is the impedance of this coil. So as you can see, the measured resistance of the coil and the measured resistance of any inductive load like a motor is going to be much lower than what the AC voltage actually sees. It's actually going to see a much higher ohms, if you will, than what you read on your meter. That's it for this video. I hope you found it to be interesting and informative. If you'd like to join our Facebook group, here is a link to it right here, or you can go to Facebook groups and type in the keyword the tech circuit. This is a link to our website right here, and this is a link to our YouTube channel. Thanks for watching.